Okay, we're going to take a look at the world's simplest sorting algorithm. So we need an array, and we will put a small number of items in our array. So it's going to be a number from 0 through 7. And let's put some random numbers in here. So we're going to be using numbers from 1 through 8. Okay, and what I want to do is I want to sort them. And the bubble sort algorithm, it's not a very efficient algorithm, but it's a simple algorithm, and if you just got a small list, it doesn't really matter that it's not very efficient. So the way the bubble sort algorithm works is like this. You start at the bottom and you compare these two numbers. Now if we're looking to get our list in ascending order, then I want the little numbers on the top and the big numbers on the bottom. So these two are out of order, so I'm going to swap them. I'm going to move the 4 down, and so we're going to look at what the next generation is going to look like over here in this column. So, and then I move the 3 up here, and I compare the 3 with the 1. And the 1 is, if you compare the 1 and the 3, 1 is already less than 3, so I leave the 3 below the 1. And then I compare the 1 with the 8, and they're out of order, so I swap and put the 8 down here and the 1 up here. Then I compare the 1, so I'm keeping moving the 1 up here. I compare the 1 with the 6, they're out of order, so I swap them, and I put the 6 down here and I move the 1 up here. Then I compare the 1 and the 2, and they're out of order, so I swap them and put the 2 down here and put the 1 up here where the 2 used to be. Compare the 1 and the 7, they're out of order, so I swap and move the 7 down here and put the 1 up here. And then I compare the 5 and the 1, they're out of order, so I swap them and I put the 5 here and the 1 here. So what have I accomplished? In one pass from the bottom to the top, I'm comparing first this pair of numbers, then this pair, and then this pair, and then this pair, and this pair, and all the way up to the top. So if there are 8 elements in the array, I have to do 7 comparisons to get from the bottom to the top. And when I get done, the only thing I know for sure is that now I have the top item in the correct spot. Okay, and then what I do is I make another pass from bottom to top. So I compare the 4 and the 3. The 4 belongs below the 3, and I just leave the 3 where it is. Then I compare the 3 and the 8, and the 8 is bigger, so the 8 gets pushed down and the 3 gets swapped up here. And then I compare the 6 and the 3. They're out of order, so the 6 gets moved down and the 3 gets pushed up here. Then I compare the 3 and the 2. Well, they're where they belong. 3 is bigger than 2. So then I compare the 2 with the 7. They're out of order, so I swap them and I put the 7 down here and I put the 2 up here where the 7 used to be. Then I compare the 2 and the 5, and they're out of order, so I push the 5 down here and put the 2 up here. I compare the 2 with the 1, and obviously on the last pass I got the smallest number in the first position. And so now I've got a 1 here and I've got a 2 here, and these two items are sorted. The rest of the array is not. So I make another pass, and I start at the bottom, and I compare those two, and they're out of order, so I swap them. I put the 8 down here, and I put the 4 up here. Then I compare the 4 and the 6, and they're out of order, so the 6 goes down here, and I move the 4 up here. Now I compare the 3 and the 4, and they're in order, so the 4 stays there, and the 3 stays there, until I compare it with the 7, and they're out of order, so I put the 7 down here, and put the 3 up there. I compare the 3 with the 5, they're out of order, so I put the 5 down here and the 3 up here. And obviously when I compare it with the 1 and the 2, they're already in their correct spots, so now I have 1, 2, and 3 in their correct order. And guess what? I make another pass. So I start at the bottom, they're in order, so I leave the 8. Compare the 6 with the 4, they're in order, so I leave the 6. Compare the 4 with the 7, they're out of order, so I swap and put the 7 down here and the 4 up here. Compare the 4 and the 5, they're out of order, so I move the 5 down here and the 4 up here. And now the first 4 items in my array are in order. And I go back to the bottom again, and I compare the 8 and the 6. They are in order. Compare the 6 and the 7, they're out of order, so I put the 7 down here and move the 6 up here. Compare the 6 with the 5, they're in order, so I put the 6 here. And the 5, compared with everything else, everything is in its correct order. And now I have 1, 2, 3, 4, 5 items in order. And it just so happens that the remaining items are in order as well. So worst case here, every time I go from top to bottom, I am making 7 comparisons. And how many passes do I need to make? Well, the first pass gets 1 item in order, the second pass gets 2, the third pass gets 3. And by the time I have 7 items in order, the 8th one has to be in order by default as well. So I'm going to make 7 passes. Okay? So this number here is n minus 1, where n is the size of the array. This number is n minus 1. So the way you measure the complexity of an algorithm is you multiply the number of comparisons total, and it's going to be n minus 1 times n minus 1, which is n squared minus 2n plus 1. And it turns out that as n gets big, it really dominates these other 2 parts here. And so we really don't worry. They become more and more insignificant as n gets bigger and bigger. What this means, though, is if I double the size of the array, then 2 squared is 4. So it's going to take me 4 times as long. If I triple the size of the array, it's going to take me 9 times as long to sort. And so if you're sorting, a really, really big array, this can make a significant difference in how long it takes you to sort the array. But the advantage of bubble sort is it's a very simple algorithm. You can remember the algorithm easily. I've never memorized the code, but I've memorized the algorithm since the first time I saw it. And if you memorize the algorithm, it's pretty easy to figure out what the code is. It's just a pair of nested loops, and your outer loop is basically going to be something like for I equals 1 to n minus 1, and that's going to control the number of passes. And then my inner loop is going to be for j equals n, which is, we'll say, is the last item in the loop, or n minus 1. If you're using a 0-based array, we'll do n minus 1. N minus 1 to, and I'm going to compare it with the 1 above it, so I'm going to go to 1, and 1 has item 0 above it, so I can still do a comparison. If I took this to 0 and tried to compare, I would end up comparing with an element that's off the edge of the array. So what do you want to do here on every pass? You want to compare the item, let's call my array A, the item at position J, and see if it is less than what's at position J minus 1, the one right above it. And if that's true, then swap those 2 elements. And swapping is just 3 lines of code, and so that is our algorithm right there. And the way the swap works is, let me just erase this right here, and we'll put in the 3 instructions for swapping. Whoops, let's get my pencil back. So I'm going to have a save position, which holds whatever's in the array. So we'll say integers like we've got over here on the left. And I'm going to put in what's in position A sub j. Okay, and then I'm in position A sub j. Since I've saved it now, I can wipe it out with what's at position A sub j minus 1. And then I can go to position A sub j minus 1, and I can put whatever I saved, which was originally what was in position A sub j. So that's how the bubble sort works.